Hello students, and welcome to Chemistry B. I'm Ms. Sleight, and today we're going to be talking about molecular formulas. Specifically, how can you determine a molecular formula from an empirical formula and molar mass? So previously we talked about empirical formulas, which are the lowest ratio of elements in a compound, which is very easy to find if you have mass composition data. However, sometimes that empirical formula doesn't actually reflect what a molecule looks like. So for example, let's take the molecule hydrogen peroxide. If you were to determine its empirical formula, you would find that it is HO. However, this is what the molecule looks like, where you can clearly see there's 2 oxygen and 2 hydrogen atoms in this molecule. So it doesn't really match what the empirical formula is showing us precisely. So in these cases, it's much more useful to know the molecular formula of the substance. A molecular formula represents the exact number of each element in a compound. So the empirical formula is just the lowest ratio of elements. A molecular formula will tell you the exact number of each element in the compound. And there are a variety of steps that we use to determine a molecular formula. The very first thing that you need to do is you need to figure out what the empirical formula for the substance is, and you need to know the actual molar mass of the substance. Actual molar mass is something that should always be given to you in a problem. Second, you need to determine the molar mass of the empirical formula. Then you're going to take the actual molar mass divided by the molar mass of the empirical, and this should come out to a simple whole number ratio. Lastly, that ratio represents how many times bigger the actual formula is as compared to the empirical. So you're going to take whatever that number is and multiply the ratio of the empirical formula by that number, which sounds a little bit confusing now, but it'll make more sense once we apply it to some examples. Our first example says hydrogen peroxide has the empirical formula HO and an actual molar mass of 34.0 grams per mole. Determine the molecular formula of hydrogen peroxide. Let's begin by identifying the 2 things that we need to start off. First off, they are giving us our empirical formula for hydrogen peroxide, and they give us the actual molar mass, and we have to determine what the molecular formula is going to be. Well, since we know both of those things, the next thing we need to do is determine the molar mass of the empirical. So if the empirical is HO, the molar mass of hydrogen is about 1.00 grams in 1 mole, plus the molar mass of oxygen, which is about 16.0 grams in 1 mole. Again, these come straight from your periodic table. And that gives us an empirical molar mass of 17.0 grams in 1 mole. Now that we know the molar mass of the empirical formula, we can compare it to the molar mass of the actual molar mass. So I'm going to take the actual molar mass, 34.0 grams in 1 mole, and I'm going to divide it by the molar mass of the empirical formula, which is 17.0 grams in 1 mole. And when you do that, you're going to get an answer of 2. This means that the actual compound is twice as big as the empirical formula suggests. So if we look, the ratio in the empirical formula is just 1 to 1. If we multiply that by 2, that makes it a ratio of 2 to 2. So that means that the molecular formula for hydrogen peroxide should be H2O2, which exactly matches what we saw in the picture of its molecule. Let's look at a second example. A sample is found to contain 7.20 grams of carbon, 1.20 grams of hydrogen, and 9.60 grams of oxygen. The actual molar mass of the compound is 180 grams in 1 mole. Determine the empirical and the molecular formula. Again, let's begin by identifying the important information. So they're giving us the mass of carbon, the mass of hydrogen, and the mass of oxygen in the substance, and they're telling us its actual molar mass. We have to find empirical and molecular formula. If a problem asks you to find both of these formulas, you must start with the empirical formula. You cannot determine the molecular formula without the empirical. So the first thing I'm going to do is I'm going to go through our usual steps of finding the empirical formula, which means starting by converting each of our mass in grams for the elements into moles, where the molar mass of carbon is about 12.0 grams in 1 mole. And then we pull out our handy dandy calculator. 7.2 divided by 12 comes out to 0.6. So 0.600 moles of carbon. And then we've got our 1.20 grams of hydrogen. 1 mole of hydrogen is equal to about 1.00 grams of hydrogen, which anything divided by 1 is itself, so this remains 1.20 moles of hydrogen. And then third, they tell us we have 9.60 grams of oxygen. 1 mole of oxygen has a mass of about 16.0 grams. And then again, we pull out our handy dandy calculator. 9.6 divided by 16 comes out to 0.6. All right, so now we need to look at our ratios to determine the empirical formula. Well, if we look here, carbon and oxygen have the exact same number of moles. That means the ratio of carbon to oxygen in this compound is 1:1. However, if we look at carbon compared to hydrogen, you might need to divide this out and just do 1.20 divided by 0.6, or you can realize that 0.6 and 1.2 are similar to 6 and 12, meaning that the ratio of carbon to hydrogen is 1:2, which, since the number of oxygen and carbon are the same, means that this ratio also applies for oxygen. So what this means is that our empirical formula must be CH2O, a 1:2:1 ratio. Now that we have the empirical formula, take a minute to pause the video and see if you can determine the molecular formula, remembering that the actual molar mass of the substance is 180 grams per mole. All right, let's see how you guys did. Remember, once you have the empirical formula, the first thing we need to do is find the molar mass of the empirical. So that means adding the mass of all of the things in our empirical formula. Well, carbon has a molar mass of about 12.0 grams in 1 mole, plus 2 times the molar mass of hydrogen, which is about 1 gram in 1 mole, plus oxygen, which is about 16.0 grams in 1 mole. And then we're just going to add these up to get the molar mass of our empirical formula. So we're going to have 12 plus 2 plus 16, which gives us a molar mass of 30.0 grams in 1 mole. Now, we're going to compare that to the molar mass, the actual molar mass of the substance. So our actual molar mass was 180 grams in 1 mole. Divide that by our 30.0 grams in 1 mole. And when you do this, this is like doing 18 divided by 3, so it's going to come out to 6. This means the molecular formula is 6 times bigger than the empirical. Well, remember, our ratio in the empirical formula was 1 to 2 to 1. If we multiply this by 6, the ratio becomes 6 to 12 to 6, which means that the molecular formula for this compound is going to be C6H12O6. And that's how you determine the molecular formula for a compound. I hope you guys have a great rest of your day, and I'll catch you next time.